Okay, hey, I think some of you guys need a little extra help, so that I've made this tutorial in order to help you with some of these reaction conversions. Mainly it's just cookbook chemistry. Just if you need to double a recipe, that's exactly what this is. If you need to triple a recipe, same thing. Okay, go ahead and read. You should have this sheet in front of you. Go ahead and read problem 1, and then highlight or circle what's given to you and what is it asking for. Okay, hopefully you said, okay, what's given to me? 1.25 grams of ammonia. And what is it asking for? Total number of grams of NO and water. So we're looking for two things here. So we're going to have to do 2 steps here. Now it seems like the main thing, people are just getting confused in their head. I don't know if that's because it's just a lot, or because of you haven't really been actually practicing like you should be. But some people who've come to me to work with me individually have kind of helped by making a schematic to help them organize their ideas. So get a separate piece of paper and make something like this with me. So first of all, there's 2 things that we've been using that can come in as what's given. So we're going to write what's given is up top. And if what is given is liters of a gas at STP, okay, that's one thing that can be given to you. The other thing that might be given to you are grams of a substance. Okay, so grams of a substance and liters of a substance. So these are the 2 things that can be given to you. And regardless whether it's liters or grams, you still have to get out of it. You have to get to moles. That's the first thing you have to do, is get to moles. And how do we go from liters to moles or grams to moles? Well, no matter what you do, it's going to be division, okay? You're going to be dividing by something. You're going to take your given and divide by something. If it's liters of a gas at STP, it'll be 22.4, okay? If it's grams of a substance, then it's going to be the molar mass. Okay, so once you figure out what's given to you, then you can say, oh, it's here, and I have to go here. That's the first step. Okay, next step is going to be you are getting your moles of your given substance. Moles of your given substance, and we got to get to moles of the asked for substance. We'll call it that. And how do we do that? We use the mole ratio from the balanced chemical equation. Okay, the mole ratio from the equation, whether it's a 1 to 2. If it's a 1 to 2, then you're going to multiply by 2. If it's a 2 to 1, then you divide by 2. If it's a 3 to 2, you multiply by 3 and divide by 2. But that comes from the equation, okay? So that's your next step. And then your last step is to figure out what is it asking for. If it's asking for you to put it in liters of a gas, or it could be asking you to give it grams of the substance, okay? These are the 2 things that it could be asking for. And how do we go from that? Well, it's the opposite of what we did before. We are going to multiply. Okay, and what do we multiply by? If it's liters, 22.4. If it's grams, the molar mass. Okay, and this is how you get for what's asked for. Okay, so that's that whole schematic right here. Start from the top, given, divide by whatever you need, then you use the molar ratio to get from moles to moles, and then you multiply to get out of moles. Okay, so keep this at the hand, keep this ready so we can go back to our example. Okay, so what is given to us in this one? 1.25 grams of ammonia is given. So on our schematic, where are we starting? Right here, grams of a substance. What are we going to have to do first? Divide by the molar mass. Okay, and that's ammonia, NH3. Okay, we're going to divide by the molar mass, so you're going to get out your periodic table, add up 1 nitrogen and 3 hydrogens. Ends up being 17.04. Gonna pause for a second. Okay, what did you guys get? We got 3 digits going in, 1, 2, 3, so 3 coming out, so it's gonna be 0.0704. This first 0 does not count. And this is moles of ammonia. So we're currently, on our chart, moles of a given. Now we have to get to moles asked for using the mole ratio. Well, there's going to be 2 of these because we have 2 things it's asking for. The first one is NO. Okay, first one's NO. And so what's the mole ratio of ammonia to NO? It's a 4 to 4, which is otherwise a 1 to 1. So that means we have 0.0704 moles of NO. Okay. Now, what about the other thing it's being asked for? Water. It's a 4 to 6. A 4 to 6 is the same thing as a 2 to 3. Now, how do you manage a 2 to 3? Well, you multiply by what you're getting, what it's asked for, which would be the 3 part. And then you're going to come back and divide by 2 because that was already attached to the ammonia. Okay, so this one we actually do have to do a little math. You should get 0.10. I'm going to round that to 6. 0.106. Okay, if you didn't get that, then let's backtrack, okay, and make sure you do. Again, you're going to take this times 3 divided by 2. Okay, so times 3 divided by 2. And this is moles of water. Okay, so now we're here. We're to our moles of asked for. And now to get out of that, we need to multiply. Now, what is it asking? Is it asking for liters of our stuff? No, it's asking for grams. So how do we go from moles to asked for? You multiply by the molar mass. So you're going to need to look up the molar masses for both NO and water. Go ahead and do that now. And we just multiply. So now once you get your molar masses, we just multiply. .11 grams of NO. 1.91 grams of water. Again, so let's go back and see how this matched our. What were we started with? Grams of the substance. We divided by the molar mass to get to moles of the given. In order to get to moles of what was asking for, we used the mole ratio from the equation. It was a 4 to 4 to get to NO, and it was a 2 to 3 to get to water. So after we got moles of our asked for substance, we multiplied by the molar mass in order to get mass of our substances, which is exactly what it's asking for. Okay, use your schematic and try the rest of these sheets and see how you do.